Good morning to all of you.
Good morning, sir.
Let's start our batting with a question like, during electrolysis of HCl aqueous, 5.6 liters of hydrogen produce at STP. For passage of same current, same charge, what mass of silver deposits from aqueous AgNO3 solution? That is all. Right. Thank you. Sir, can you work out this, sir? Whenever I am passing current that is equivalent to 1 Faraday or that is equal to 96,500 coulombs approximately, or equal to Avogadro number of electrons, I always get 1 gram of hydrogen, that is its equivalent weight. Or I get 8 grams of oxygen, that is its equivalent weight. Or I get 35.5 grams of chlorine. You know that, sir? Hello? Hello?
Yes, sir.
Yes.
Sir, 1 gram of hydrogen means actually molecular weight of hydrogen is 2. 1 gram means half mole. Half mole means 11.2 liters of hydrogen at STP. This is equal to 8 grams of oxygen means 1/4 of molecular weight, 5.6 liters of hydrogen at STP. This is equal to 11.2 liters of chlorine at STP. If you are talking of silver, this is equal to 108 grams of silver because that is its equivalent weight. It is equal to 23 grams of sodium because that is its equivalent weight. It is equal to 20 grams of calcium or it is equal to 12 grams of magnesium. Or it is equal to 31.75 grams of copper if you are electrolyzing copper sulfate. Ladies and gentlemen, you get 8 grams of oxygen if aqueous solutions are subjected to electrolysis. If you are subjecting H2O2 to electrolysis, then the story thoda alag hota hai. Because in H2O2, O2 is 2 minus. Therefore, you will be getting for passage of 1 Faraday from H2O2, double the amount of oxygen, that is 16 grams. You should always look at what you are electrolyzing. When you are electrolyzing copper sulfate Cu plus 2, then the equivalent weight of copper is atomic weight by 2. If you are electrolyting Cu2Cl2, cuprous chloride, then the equivalent weight of copper is equal to atomic weight because valence is 1. So you should be in the lookout. In electrolysis, these are the products. If you know this fundamental table, you can see the answer. For every 11.2 liters of hydrogen at STP, you will be getting 108 grams of silver. If you are using 5.6 liters of hydrogen current or charge, you will get 54 grams of silver. You can extend it even for aluminum. It is equal to 9 grams. Sir, is it difficult to remember this, sir? Hello.
Once can you explain again?
Excuse me?
Did not understood, sir.
Congratulations. What you did not understand, you have to tell me. Slowly we will go. We are not in a hurry. From Faraday's second law, passage of 1 Faraday charge or passage of 1 mole of electrons are 96,500 coulombs. Through any electrolyte gives one equivalent mass of element at electron. Always equivalent weight is equal to atomic weight by valency. For any acid, equivalent weight is equal to molecular weight of acid by basicity. Basicity means number of H plus ions it can give per molecule. Or equivalent weight of any redox reagent, that which can undergo reduction or oxidation, is redox reagent molecular weight by number of electrons it is gaining or losing in the course of reaction. For example, the equivalent weight of silver is its atomic weight 108 divided by its valency 1. The equivalent weight of aluminum is its atomic weight divided by usual valence of aluminum 3, 9. The equivalent weight of magnesium is equal to atomic weight divided by its usual valency 2. The equivalent weight of hydrogen is equal to atomic weight divided by its valency 1. Any difficulties there?
No, sir.
The equivalent weight of oxygen is equal to atomic weight divided by its valency 2. If you are considering copper sulfate, where copper is plus 2, its equivalent weight is equal to atomic weight, which is 33.63.5 by valency. In some books, they close it to 32, no problem. If you are electrolyzing cuprous chloride, Cu2Cl2, then equivalent weight is equal to atomic weight by valency. If you are using S2O2, equivalent weight is equal to O2 is 32, equivalent weight of oxygen is equal to O2 divided by valency of O2 is 2. It means for a H2O2 oxygen equivalent weight is 16. For a H2O oxygen equivalent weight is 8. Always look at the atomic weight, divide with the charge. Here in water it is H2O minus 2. In hydrogen peroxide it is O2 minus. Here equivalent weight is 8, here equivalent weight is 16. Because there is a difference. Can you see? Hello? Hello?
Yes.
Ladies and gentlemen, here just now you have seen that. Just now you have seen that. From Faraday's first second law, passage of 1 Faraday of charge or 96,500 coulombs or 1 mole of electrons through any electrolyte gives one equivalent mass of any element. And the equivalent mass of any element for silver means silver plus. So atomic weight by 1, so on. And generally, this is the formula to get the equivalent weight of any element. It is the formula to get equivalent weight of any acid. For a base, molecular weight of base divided by OH minus ions amount of kilo base can give. For a redox reagent like KMnO4, when KMnO4 is taken, manganese is plus 7. Suppose if the KMnO4 is becoming Mn plus 2, then the equivalent weight in this case is molecular weight of permanganate by 5. If the KMnO4 is becoming simply MnO2, plus 7 is becoming plus 4, then the equivalent weight of permanganate is equal to molecular weight by 3. In some cases, KMnO4 will become potassium manganate, K2MnO4. Here manganese is plus 7. Here it is plus 6. In this case, equivalent weight is equal to molecular weight by 1. We are using 1 because it is gaining only 1 electron. Here we are using 3 because gaining 3 electrons. So for a redox reagent, you have to see how many electrons are gained or lost. For example, if I am taking iron oxalate, iron is a plus 2 and each carbon is plus 3. In the course of electrolysis, iron becomes plus 3, oxalate will become carbon dioxide. That is plus 4 carbon. So total positive charges in the product are 3 plus 8, that's equal to 10. And that's equal to 11, sorry. Here total positive charges are 2 plus 6, that is equal to 8. Total 8 positive charges are becoming 11 positive charges, means 3 electrons are lost or gained, sir? Hello? Is it a gain or loss?
Lost.
So the number of electrons lost is 3. Therefore, equivalent weight of ferrous oxalate in this reaction is molecular weight by 3. Are we very clear about it? Hello?
Yes, sir.
Yes, sir.
Sir, whenever you are saying 1 gram of hydrogen at STP, it is corresponding to 2 by, 1 by molecular weight of hydrogen is 2. Do you remember molecular weight of hydrogen is 2?
Yes, sir.
Yes, sir.
It implies that 2 grams occupy 22.4 liters at STP because 1 mole of any gas occupies 22.4 liters. For example, molecular weight of oxygen is 32. It implies 32 grams of oxygen occupy 22.4 liters. You know, chlorine molecular weight is 71. It implies 71 grams of chlorine occupy 22.4 liters. Gram molar volume. If you are having only 1 gram of hydrogen at STP, 2 grams is equal to 22.4. 1 gram will occupy 11 parts. Any problem?
No, sir.
You are saying 32 grams of oxygen at STP occupy 22.4 liters. 8 grams of oxygen occupy 5.6 liters. Therefore, I am saying that one equivalent weight of any element here I have taken. Whenever I am passing 1 Faraday charge or 96,500 coulombs of Avogadro number of electrons, I am usually getting 1 gram of hydrogen. The 1 gram of hydrogen at STP occupy 11.2 liters. I am getting 8 grams of oxygen at STP, 8 grams occupy 5.6 liters. I am getting 35.5 grams of chlorine at STP, it occupies 7.2 liters. From copper sulfate for passage of 1 Faraday, I get this much. Silver, this much. Sodium, this much. Calcium, magnesium. Only. Now, what is the difficult thing in this, sir? Hello. Ladies and gentlemen, if I remember this table, I can answer a question in say 10 seconds. They will tell me during electrolysis, I got 22.4 liters of hydrogen at STP. For the passage of same charge through molten NaCl, what mass of sodium I will get? I know 11.2 liters of hydrogen is corresponding to 1 gram, that is corresponding to 1 equivalent weight. Same 1 equivalent weight of sodium I will get. For 11.2 liters of hydrogen, I can also get 23 grams of sodium and electrolyzed using molten NaCl. Any problem, sir?
No, sir.
Suppose somebody got 60 grams of calcium during electrolysis. For the passage of same current, what volume of hydrogen I will get? You got 60 grams calcium. What volume of hydrogen I will get? Hello?
Eleven point two.
20 grams of calcium implies 11.2 liters. 60 grams imply 33.6 liters. So one can read this if one is familiar. Are we clean?
Yes, sir.
In electrolysis, the criteria of product formation depends on the individual electrode potentials. Suppose if I am subjecting a solution, aqueous solution, that contain fluoride ions, iodide ions, and I am subjecting it to electrolysis. Which X minus first loses electron to give X2? Which will
Fluoride.
Iodine.
Iodide ion loses electron most readily because
Lowest SRP.
its discharge potential is least, or I would say that its SRP, standard reaction potential, is least. Fellow with lowest reduction potential or fellow with low discharge potential will be released first. Notice, low discharge potential, low SRP are same in case of oxidation. Low SRP and low discharge potential are not same in case of reduction, mind you. If you want to have reduction, fellow with a high SRP undergoes reduction first. Are you clear about it, sir?
Yes, sir.
Now we are going to look at next idea. I have taken sodium acetate. I have subjected to cold electrolysis using, say, 4 Faraday's charge. Now, what are the gases I am getting at anode? What is their volume? It is for IIT box. Notice, hydrogen and NaOH are produced at cathode. Whenever I take sodium acetate, 2 moles of it react with water in presence of current, so that I get NaOH 2 moles, H2 gas 1 mole, CO2 2 moles, and ethane 1 mole. Notice carbon products will come at anode, so I will be getting 1 mole of ethane and 2 moles of CO2 at anode. Hydrogen products come at cathode. Now, in order to get each NaOH, I need 1 Faraday charge. So here I am getting 2 NaOH, means total I need to use 2 Faraday charge. So for 2 Faraday, sir, how do you know it is 2 Faraday, sir? Please tell me, sir. Notice, unipositive or uninegative ions will interact. when there is 1 Faraday charge. Here CH3COO 2 moles are reacting. Therefore, there are 2 Na plus. Sir, how do you know that 2 moles are reacting? Whenever a sodium salt or carboxylic acid is undergoing hydrolysis, you always get H2 as a product. H2 is possible only when 2 moles react. So, as a summary, when sodium acetate is subjected to electrolysis, at anode I get carbon-containing gases, at cathode I get hydrogen-containing materials. So here I am saying that for 2 Faradays charge, I get 1 mole ethane, 2 mole CO2. For 4 Faradays, you get 2 mole ethane, 4 moles carbon dioxide. That's the answer. Is it confusing, sir? Somebody has a plank of 2 meters length, two meters width, 3 meters long, and he wanted to have 0.01 millimeter thickness. If you want to coat a copper over a plate of these dimensions, what are the dimensions, sir? 2 meters width, 3 meters long, 0.01 meter, let us say, not millimeter, thick. Copper coating not applied on one side. Now, if density of copper is equal to 9 grams per centimeter cube, through copper sulfate aqueous solution, how long I should pass current? I repeat, I have a plank that measures 2 meters width, 3 meters long, 0.01 meter thickness copper I want to coat. I want to do it by passing current through copper sulfate solution. If the density of copper is 9 gram per centimeter cube, how many Faradays of charge or how many coulombs of charge is needed? I will write the problem. Sir, I have a plank like this. On this plank, I want to coat copper. That is my dream. If I want to coat copper, I should place the plank in a vessel that contains copper sulfate. Fellow which I want to coat copper is to be taken as cathode. Pure copper wire is to be taken as anode. You take copper sulfate solution as electrolyte. My problem is how many coulombs of charge I should pass to achieve this objective. If density of copper is given as 9 grams per centimeter. Can we solve it, sir?
Yes, sir.
Sir, the total volume of the metal I need to deposit on one side is 2 into 3 into 0.01. That is equal to 0.06 meter cube. Can you see it, sir? Hello?
Yes.
Meter cube. Meter into meter into meter. But I want to hear it in centimeter cube. Why? Because they gave me density of copper in centimeter cube. How can I convert meter cube into centimeter cube? Means cut the meter. Instead of the meter, you need to write 10 to the power 2 centimeters, 10 to the power 2 centimeters, 10 to the power 2 centimeters. So, what is the volume of thickness I should go for? Means 0.06 into 10 to the power 6. That's called how much, sir? 6 into 10 to the power 4 centimeters. Are you seeing it clearly, sir? Hello?
Yes. Sir.
Hello. 6 into 10 to the power 4 centimeter cube is the area I need to quote. Now I want to know density is equal to what, sir?
9 centimeters. 9 grams.
It means 1 centimeter cube is equal to 9 grams. 6 into 10 to the power 4 centimeter cube is equal to how many grams? Are you clear, sir? Hello? Hello?
Yes,
Yes,
sir.
sir. Clear.
So I need to cover 64 these many grams. Yes or no?
Yes, sir.
Hello?
Yes.
I know. How many grams of copper I want, sir? Hello? How many grams of copper?
54,000.
60?
54, sir. 54,000.
Not 1000. 4 zeros, no?
Yes, sir. Yes, sir.
Can I make the calculation, sir? Sir, can you simplify it?
1.7 into 10 power 4 grams.
No, this is grams. This you will be getting Faradays.
Faradays.
Can you see? This is the problem that you can expect on Faraday's laws. In fact, I have shared one material with you. What is that material I have shared, sir? I have sent you that book actually. I don't know whether you received it. This is the book I have shared with you. Did I?
Yes, sir.
For this exam, I want you to prepare only basic level questions, concept understanding type questions. You need not have to worry about electrolytic conductance, which we have not done. All other questions we have done, you should try them. Don't do the.
It's at 20 to 64, sir.
Don't do this. Start at 22. Do as many as possible. Read the NCERT. Get with your doubts. Now, can I take you to next idea?
Yes, sir.
Or should we solve some problems in this? Any doubts you have?
Solve some problems.
You have any doubts? On electrolysis, 1 mole of aluminum atoms will be deposited by. Aluminum is usually +3. Is it or so? AlCl3, Al2O3.
3 moles
Aluminum is
per
usually-
electron.
So you need to pass 3 moles of electron. That is 3 particles of charge. For the cell reaction to be spontaneous, the EMF of the cell should be, whenever the EMF is positive, then only the cell works. If the EMF of the cell is 0 or negative, it will never work. The EMF of galvanic cell is determined by using what, sir?
Voltmeter.
Voltmeter.
Voltmeter connected parallel to
Circuit.
circuit. Can you answer question number 51? Can you answer question number 51?
Cell potential.
Yes, sir.
Yes, sir.
52.
Sir, we cannot see.
Can you see?
Yes.
Notice that the zinc has a SRP
only
negative minus 0.76. Copper electrode potential is plus 0.34. You should remember
1 and
3,
2.
4 values.
Sorry, 1 and 3.
Therefore, zinc has a lower reduction potential and can lose electrons to copper +2. Copper is deposited. Magnesium has a much lower SRP than copper. So again, magnesium can lose electrons and copper is deposited. Silver is having higher SRP. Silver can never lose electrons to copper. Number 2 is impossible. 1 and 3 to happen. Are we clear?
Yes.
Yes.
Can you answer question number 16?
This one is not correct, sir.
I want you to try as many questions as possible in a C concept type. This is the lowest grade. Once you are through the concept level questions, then in the same topics, you should go for level 1. This time I want you to cover up to level 1 only. Concept type and level 1. See, in electrolysis, level 1 class work. Notice question number 2. If mercury is used in present as a cathode, in the electrolysis of aqueous NaCl, notice normally in aqueous NaCl, there is a competition between Na plus to gain electrons and water to gain electrons. Because the reduction potential of Na is much less than that of water, water wins the race. H2O plus electrons gives H2 gas plus 2OH minus. So always 2 H2O molecules gain 2 electrons to become hydrogen. H plus wins over Na plus. However, if I am putting mercury in the solution, in presence of mercury, sodium can make sodium amalgam, because of which the water will be unable to take electrons. Na plus take electrons to become Na amalgam. Water is not undergoing any change if there is mercury. Which of the following occurs at cathode? Can you say which occurs at cathode? At cathode always there is reduction. Red cat, anox. Reduction
Option
means
4.
gain of electron. The electrons are gained only in 4th option. So only 4th thing can happen. Can you answer question number 10? Whenever I am taking Na2SO4 and using platinum electrodes, the Na has lower reduction potential than water. So it will not gain electrons. The sulfate ion has higher reduction potential than water. In other words, sulfate ion has lower oxidation potential than water. So for oxidation, fellow with high oxidation potential undergoes oxidation. For reduction, fellow with high reduction potential undergoes reduction preferably. Therefore, neither the sodium ion nor the sulfate ion undergo any change in the electrolysis. In a diluted solution, first the water will undergo reduction and produce H2 gas OH minus. At the other electrode, water will undergo oxidation to produce O2 gas. What gas, sir? O2, sir. Sir, SO4 2 minus, it has to lose electron, but it can't lose electron because there is water who is willing to lose electrons. When water loses electrons, sir, 2H2O can lose 4 electrons to give 4H plus and O2. Notice, when water undergo oxidation, you get oxygen gas. When water undergo reduction, you get hydrogen gas. Therefore, in the electrolysis of sodium sulfate, both at cathode and anode, it is the water that undergo discharge. So you will be getting H2 and O2 gases. However, if the sodium sulfate, ammonium sulfate, sulfuric acid is more concentrated, then sulfate ion itself can lose electron to become S2O8. So there is a point of difference. Now, can you answer question number 10?
7 options.
All the options.
Option B, sir.
Option 2, you mean?
Yes, sir.
Anybody is having objection to this, sir? Question number 10. Option 2 is saying I did not see. I want you to see and tell me. Anybody is having objection. Whenever you are electrolyzing aqueous Na2SO4 using platinum electrodes, oxygen gas comes at anode and hydrogen gas comes at cathode is 2. The charge carried by Avogadro number of electrons is called 1 Faraday, that is 2. The amount of electricity required to deposit 27 grams of aluminum at cathode is 3 Faradays, that is for sure. A gas in contact with an electrode, inert electrode is what, sir?
Hydrogen.
Therefore, you answered this question. Yes or no, sir? Hello? Hello?
Yes.
I want you to try level 1 questions, level 1 classwork, level 1 homework containing problems on Faraday's laws, problems on electrode potentials, problems on Nernst equation. You need not have to worry about conductance and all we have not covered. Did I share this material with you? Hello? Hello?
Yes.
Yes, sir.
So
Yes,
please,
sir.
you can read the content also if you want. Now, next week we plan to complete electrochemistry. This week we have gone very slow, unfortunately. Now, please ask me all your doubts. In the electrochemistry topic, we have covered 2 important ideas. In chemistry, electricity is generated by using certain reactions which happen by themselves. Electricity is consumed to bring about such reactions which cannot happen by themselves. A cell where current is produced is called electrochemical cell. A cell where electric current is consumed is called electrolytic cell. We have seen the differences between these 2 cells by and large. You can ask me if you have any doubts, sir. You don't go away. Stay in the class. Try to do at least 5 questions now before we close. In level 1, we come from question number. Don't do questions on conductance, molar conductance at infinite dilution. equivalent conductance, electrolytic conductance. Don't do all those things which we have not covered. All of you, can you answer question number 30? Hello, sir. Question number 30.
Yes. Option 2, sir.
Option 2, sir.
Hello.
Hello. Hello. Hello, sir.
Yes,
Yes,
sir.
sir.
Now I have a very important message to give. I am giving you the message. Ladies and gentlemen, when you are maintaining electrolysis, please look here, whiteboard. Yep. When you are passing current, if you are using, say, two copper electrodes, copper is cathode, copper is anode, both are. And you take copper sulfate solution as electrolyte. Sir, when you are passing, the rule is, at anode, copper undergoes oxidation and it enters into solution. At cathode, copper gets deposited. The copper sulfate solution will allow the movement of ions. Now, if you pass current for 1 hour, the concentration of copper sulfate always remains same. Because in one end, copper is getting dissolved, in another end, copper is getting deposited. It means some reaction is happening at both the electrodes. Hence, they are called active electrodes. Notice, whenever I am using active electrode, always at anode there is oxidation. NOx red cat. Oxidation means copper, in this case, loses electrons and gets deposited at cathode. Okay, sir? So, if you take 1 kg anode, at the end of the experiment, the weight of anode will decrease. At the end of the experiment, the weight of cathode will, hello?
Increase.
Now, ladies and gentlemen, you want to give one ornament to your girlfriend, but you are planning to cheat. It is made with copper. You want it to be coated with silver. Because copper is cheap, silver is costly. Just you will give a coating. Okay. So, how this can be coated with silver?
Electroplating.
Take the ornament which you want to coat with silver as cathode. Okay, sir? Now take pure silver rod as anode. Okay, sir? Okay. Connect these two. Here put silver nitrate solution. Always at anode, if you take silver, silver will lose electrons and can dissolve. The same silver will go to cathode, there Ag plus will take electron to become silver. So the instrument or the article which you want to coat with a precious metal or the article on which you want to deposit any other element must be taken as cathode. The metal which you want to deposit, which you wish to dissolve and deposit, is to be taken as anode. And the salt solution which contain an ion which you want to deposit in aqua solution should be taken as electrolyte. You got it, sir? Hello?
Yes.
Yes, sir.
Now here is an interesting question. Cost of silver. What is the cost of silver per kg, sir? Oh. Hello? What is the cost of silver per kg? No idea, no general knowledge. Nobody is telling me, man.
10,000
Hello, sir.
rupees.
Please tell me, sir. What is the cost of silver, sir? Please. 1,000 rupees? You stupid fellow.
10,000, sir.
My sister చెప్తున్నాడు cost of silver kg 1,000 rupees. What is the cost of silver per kg, sir?
63,000. 63,000.
65,000, let us suppose. Now, on your silver, on your copper article, you pass current for, say, 100 seconds. What is the cost of silver you deposited? You pass 100 seconds, 1 ampere current. What is the cost of silver you deposited? If the volume of the article on which you are depositing is, don't worry about volume. You pass a current for 100 seconds, 1 ampere. What is the cost of silver you deposit? How to solve this, sir? If cost of
Faraday.
silver, sir,
We can use Faraday's.
I am saying 100 seconds into 1 ampere is equal to 100 coulombs. Yes, sir?
Yes.
Hello? Now you know 96,500 coulombs is equal to 108 grams of silver. Do we know that, sir?
Yes.
Yes, sir.
100 coulombs is equal to how many grams?
Yes.
Yes, sir?
Yes, sir. 1/9, sir.
It is 1/9 grams.
0.1 gram.
0.1 gram. You know, 1,000 grams is equal to 65,000. Okay, sir? 0.1 gram is equal to how much?
6.5
What 6.5?
Rupees.
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 So for your girlfriend's sake, you have spent how much money?
6.5 rupees.
Plus cost of the original copper ornament will be half rupee. 7 rupees.
7 rupees.
The article looks as if it is worth some 15,000 rupees. But really it cost is how much?
7
11
rupees.
rupees.
That's very interesting. But if somebody will take that ornament and scratch, the silver coating will disappear and you can see red color copper. So you should handle it carefully. You understand? Okay.
Yes, sir.
Now there is another interesting question. A bit difficult. 100 seconds, 2 amperes, current, but current is 50% efficient. Now, on a surface of how many atoms are deposited? Hello, sir. Obviously, the current is 50% efficient, means though you take 2 amperes, it is 50% of 2 amperes is deposited. The current is not efficient. If you take 1 ampere, it is not 1 ampere, it is only half ampere, 50% efficient. So, what is the total charge you maintain? You have maintained 100 coulombs. Can you see it, sir? You know, 96,500 coulombs is equal to 1 equivalent weight of copper, that is 6 into 10 to the power 23. If it is only 100 coulombs, how many atoms? You can solve it now. 6 into 10 to the power 23 by 96,500 into 100. Can you see it, sir? Hello.
Yes.
It is equal to 6,000 into 10 to the power 23. 6 into 10 to the power 23 is equal to 6,000 into 10 to the power 20. So how many times it will go, son? These many atoms here are possible. 6.5 into 10 to the power 20 atoms. You understand, sir? Hello?
Yes, sir.
Yes.
So many atoms, really. Okay? There can be many tricky questions on Faraday's laws. I don't want to lose the flavor by speaking myself. You can see questions on Faraday's laws in first concept CPU, and then level 1 classwork, then level 1 homework, then level 2 classwork, level 2 homework. Don't try to do all this. We have no time. Randomly you do 3 problems in levels, but all problems in concept. Okay, sir? CUP,
Yes, sir.
concept and understanding type. First, you do all. Concept is important. Also, you should support yourself by reading NCERT book about what are electrode potentials, how to find the single electrode potential, what is standard hydrogen electrode, what is the way to find the cell potentials, what is Nernst equation, how to use the Nernst equation to know cell potential under different concentration pressure conditions, then what is the electrochemical series, and which elements are there in the top position, which are in bottom position. Then you should see what are Faraday's laws, and then you should solve simple problems related to these two concepts. The remaining part of this lesson is how to measure the conductance, what are the factors that influence the conductance, and now what is the importance of finding conductance of electrolytic solutions, and then what are the different types of cells we have in our day-to-day life. In car and in lorries, what type of batteries are used? What are secondary cells that can be recycled again and again? You can recharge them again and again. What is the type of cell that is used in your watches? Finally, what is corrosion and how to prevent it? These are the aspects which we study next week. This week only this introductory part. Read the NCERT, try to do problems from the material I have sent and also from exam plan. Any more doubts, sir? Always post me your doubts through WhatsApp.
No,
I am always there. Okay? I try to upload one video if you ask me
Yes.
doubts. Monday we will be meeting. Thank you.